on the TI. This is called estimation, okay? So I'm going to go through some of those notes on it, and I'm going to put it in the comment section for you guys, okay? As well, and let me download it myself in Canvas. Okay, so I'm going in Canvas now, or my website under, you guys can see this under estimation. I'm going to put those notes in, and you guys create a new note. And you guys are what section again?
16324.
All right. Okay, we got the notes. And so let's go through this really quickly because this is about reading and following instructions. And this is going to be on your test, okay? All right, so I'm going to start off here by saying a few things here about this. You guys know. Let's read through. This is about estimation, okay? So we are going to estimate what's called a population parameter. Now, generally speaking, we have 4 population parameters, okay? And here's what they are, and we're going to estimate all of these parameters here. Mu is mean, P is proportion, sigma squared and sigma, variance and standard deviation. These are also known as true values. So as we actually do this, you're going to see that phrase, estimate the true values here, okay? But they're known as population parameters as well. So you might say, okay, what's a population parameter? Well, if you were to conduct a census, and a census is if you were to ask everybody, is that right? You guys remember those definitions? Mm-hmm. And you have something called a population size N. That's when you ask everyone. So we're going to start today by estimating a population what? Mean. And this is also AKA a true mean. So notice in the definition, you got the capital N, which is going to be, that's the population size. So that's if you asked everybody. And if you asked everybody, there would be no need to take a sample because you're asking everybody, right? This is a true value. Now, we're going to get to these called true proportions, which is a true percent or a true probability. True variance, now this is the shortcut formula. Shortcut formula for the true variance. And then you have what's called the true standard deviation. So all of these are known as population parameters, okay? That's assuming you take a census and ask everybody. But essentially, we can't take a census. You say, why not? Does anybody remember why we can't take a census? Nope. It's too time-consuming and too what? Expensive, because you got to pay people to do it. So the best you can do then will be to do the following, which is known as approximate that parameter. Okay? you're going to approximate with these things called point estimates. These are all now approximations that are based on a sample of sample size n. So ladies and gentlemen, we'll be taking a sample and we're going to approximate the means, the proportion, variance, and standard deviation with these measures. And they're known, by the way, these point estimates are known as statistics, and that's the name of the course. So point estimates are also known as statistics. You're checking statistics. All right, here's your population. Here's your sample. This is data. And we're going to be using today a sample what? Mean. Okay, so we're going to be computing today. We're going to be using this information. A sample mean. Now, a sample mean is a mean that's based on a what? On a sample. Is that right? So you're going to be taking a sample, not a census. And in fact, specifically today, it's going to be a large what? Sample. What's a large sample? Do you guys remember? Anything that's what? Yeah, bigger than 30. So there's the deal. And this is related to the central limit theorem. Because the sampling distributions of the mean is normal if the sample is large enough. It's a normal distribution. And that was what we talked about, last week and gave you the notes and did homework on, right? So anyway, here's the real information behind this. Even though this is a sample mean, ladies and gentlemen, we're going to be conducting what's called an interval estimate. And an interval estimate for today, I think we're going to do, this is for the true proportion, but I think we're starting with a mean large sample. I can't remember. But you know what? We don't have to. We can start with the proportion large sample. How's that? So you might say, can you go back and talk about this again? Well, a sample proportion is right here. And let me double check online. What do I have first? Because I thought I did that earlier. Well, no, we're going to do the mean. Sorry. We'll do the mean. Okay, so I'm going to go, we're going to do the mean just like we talked about. So I'm going to scroll all the way down. And you can say, okay, where is this all? Here's what we're going to do. Estimate a true mean here, okay? So it's also the population mean, mu. Now, it's going to be what's called an interval estimate or confidence level estimate. So notice this. This is what you guys want to see here, okay? To the left, you have what we call a lower value estimate. That's a lower value. And then to the right, ladies and gentlemen, we have an upper value here, okay? So we have a lower value and an upper value estimate of this true what? Mean mu. So we're going to make an estimate of mu for a large what? Sample. Okay, now technically there's something called a margin of error here. So E is going to be known as your margin of error. And it's represented by a capital E here. So you go, oh, okay. E is the margin of error. What is the rest of this stuff? Well, you got what's called a z-value, and maybe I'll put that purple. It's really a z alpha over 2 value. We'll talk about that. This is a true standard deviation, and then you have a sample size. And this is for when sigma is known, or you have a large what? Sample. So you're going to take a large sample. Estimated true mean mu. All right. Now, the stuff on the left really comes from a sample. The lower value and the upper value both come from samples. So what we're going to simply do is read the questions, get your sample information, and then compute this interval estimate on the true mean. Okay? And this is based on what's known as the Z distribution. Now, the Z distribution is known as the standard normal distribution. So I'm going to give you some theory here. It's a normal distribution. It's a bow. It's a very special normal distribution. It's called the standard normal, where the mean is 0 and the standard deviation is 1. And every one of these interval estimates will have what's known as a confidence level. And we're either going to have what's called the 90% confidence level, the 95% confidence level, or the 99% confidence level. And we'll talk about all those details, you know. And again, I have this in the notes. It's a very simple process and a simple idea. There is some technical definitions, but I'll go with some of these ideas here. It's really not that important to do at this point because we're going to use the what? The TI. All right? So you guys know, but we'll be working more of this with this stuff in our future. This is part of the notes I gave years ago where you had to use a Z table and people had to get those Z values associated with all these confidence levels, 90%, 95, 99%. We even talk about what it means. But back in the day, we had to do a lot more work without the TI. This is all what you'd have to use without the TI. I have videos online, but let's go through, ladies and gentlemen, a typical example and show you guys how to do this with your TI, okay? We're just going to estimate a mean. And I'll go with some questions like, for example, that, you know, are relevant to college students. That's what I kind of like to do because in theory, you guys should be interested in these ideas because you're college students. All right, so let me give you guys an example to share with you guys what I mean, right? I call this the years in college. So believe it or not, students spend a certain number of years in college, and that's kind of important. Do you guys know what I'm talking about? It's kind of a big deal. It's more of a big deal than you realize, right? Because college is supposed to be for how many years? How many years are you supposed to take to get a bachelor's degree? How many? 4 years. All right, you guys okay with that? Now, Mr. Judge was a former ELAC student. He was one of you guys here. He used to sit not in these rooms because these rooms are new. But Mr. Judge was one of those ELAC students. Okay. Do you know how many years it took me, ladies and gentlemen, to leave ELAC with an AA? 4 years. So, okay. Now, I was a part-time student. I went to school at night. You know, I was taking care of my parents. I didn't have kids at that time. I was taking care of my parents and my grandparents. working full time and then going to school part time. So I was one of those students. So it took me 4 years before I graduated. Okay. So when you start to read some of these questions, some students have taken, so it actually took me more than 4 years to get a bachelor's degree. I think it took me like 7 years to get a bachelor's degree. And then it took me 3 years to get a master's degree. So I was like a college student for 10 years. So that 10 years should have really been, in theory, 6 years. Is that right? Do you see my point? Is there anything wrong with all of that? Why not? Because it doesn't matter where you start. It matters where you what? End. I just want to share that with you guys. All right. So this is an example. So what's this an example of? A sample of 600 college students indicate it took them a mean of what? 6.5 years. Hey, this is a made-up kind of example. With a standard deviation of what? 1.8 years to earn a bachelor's degree. And now what are they saying here? Use the what? 99% confidence level to estimate the true mean years it takes to earn a bachelor's degree. So I'm going to go through this, read it again, and I'm going to use colors, and I'm going to be consistent with my colors. I always put my sample information in red. So they say a sample of what? 600 college students. What do you think they just told me when you read that? What is good? N is what? 600, and it is large. And it took them a what? A mean of what? Okay, good. What do you think that means, ladies and gentlemen? It's a mean that came from what? A sample. So that's the X bar. That's the sample mean. Yes. Easy peasy. We're just reading. And then you have a what? Standard deviation of 1.8 years. Okay. And what is that? S. So I just want to stop right there and remind you guys that the sample information, and I write that stuff down. N is what?
600.
Sample mean is what?
6.5.
Sample standard deviation is?
1.8.
So far, so good? Language and what? Process. Okay. Now, that's sample. Now, they say use the what?
Or 99% confidence.
Yeah, and I guess I'm going to use, I can't remember what colors I'm using. Let's use purple, I guess. Use a what? 99% confidence level. Didn't I tell you guys that the bow there is 99%? And then what do they want me to do? Estimate the true what? Mean. So that is mu, the true mean. So I'm going to say to you guys, that's all you got to really do in some ways. Is know you are estimating what? The true mean. You're estimating mu. And how do you guys know that? They're going to tell you. You got to read it, okay? So you're estimating mu, the true mean. Now, okay. Really, back in the day, I'd have students write down E error minus the what? Oh, no, sorry. It's the sample mean minus the error less than mu less than the sample mean plus your error. And yes, back in the day, I would tell students, you're going to have to get a lower bound value and then get a what? Upper bound value using your formulas. And they'd use their regular old calculator using their what? Formulas. But now we're going to use the what? The TI that you guys all rented. You guys okay with that?
Yep.
So you're going to use that TI calculator. Now, I want to remind people, 99, the confidence level, I write down here too. I'll put CL, by the way, is 0.99. Why did I put 0.99?
Because 1 is 100%.
We changed 99% to a decimal. Good. And then, are you guys ready? Here's what you guys got to do in the TI. You're going to go now in the TI here to something known as stat test. I'll show you where that's at. And you're going to use Z what? Z interval. You're going to use Z what? Interval. So, you might even want to write that down. Do I have a little cheat sheet for you?
Yeah.
Yes. So you say, oh, Mr. Judge, thank you. Huh? Okay. So language and process. This was the language. Let's do the process. Okay. So I'm going to clear this out, and I'm going to say, okay, you're going to go to stat what? Test. Where else do you go? I don't know where that's at. Let's go Z interval.
7.
You guys are right. Number 7. You guys see that there? Hit enter. Okay. Go down to sigma. You say, what in the world is sigma? It's the... Sorry, wrong button.
Are we on data or stats for that?
Stats.
Stats?
Sigma is what you're using here, okay? That's the standard deviation. It's really the true standard deviation, but you have a large sample, so we don't need to know that. That's what's going on. Because you have a large sample, we get to use the sample standard deviation instead. So that's an important detail. So here's what I'm saying. What's the standard deviation again? 1.8. You guys okay with that? So I'm going to go here and change that to 1.8. Good. What's the sample mean? 6.5. You guys good with that?
Yeah.
What's the sample size?
600.
600. Good. What's the confidence level, ladies and gentlemen?
0.9.
0.99 for 99%. And you know what? You're done. Just go and hit what?
Enter.
Calculate. And you know what it just did? You know what you guys have? You have your answers. Let's go to the nearest thousands. You see that first number on the left? What is it? Yeah, it's 6.31. What's the 0? Look to the digit to the right. What is it?
6.311.
6.311. That's the lower value. We now need the what? What's the upper value to the thousands?
6.689.
And then, ladies and gentlemen, guess what? You're done.
I thought that would be way more painful.
You're done. Easy peasy lemon what? Squeezy. So, ladies and gentlemen, this is what they're looking for. What that means is the true mean years it takes college students to get to a 4-year degree is between 6.311 years and 6.689 years. And then we say this with what's known as 99% what? And we'll talk about that detail as soon as we get some of these under our belt. So what do you guys think? Language? Process. You just estimated the true mean. Mu, sigma. And yes, it's a normal distribution. Anyway, ladies and gentlemen, this is a result of that sample distribution of the means question. Easy peasy lemon squeezy. Look at this. Isn't this even in your notes? Does anybody print them out?
I do.
Good for you. Here's another example I'm going to go over, but I kind of don't like this example because it depresses me. It's horrible. It's not real. Okay, do you guys know celebrity net worth? What does it say? A sample, so this is a sample of what? 65 celebrities. What do you think that means? Sample size? 65. So they took a sample of 65 celebrities, they were surveyed, and they reported a mean net worth of what?
200 million.
So that's a mean, ladies and gentlemen. Okay, so this is a mean from a sample. It's known as a sample mean. You okay with that? All right. What's the sample standard deviation? How consistent is that number? $28.5 million. Use the what? 95% what? Confidence level to do what? To estimate the true what? Mean net worth. So this was only 65 celebrities. There's a lot more than 65. So what's going to happen now is I'm going to write this down. What did I get from the sample? What's the sample size?
65.
What's the sample mean?
200 million.
I'll put just 200M, but we'll just use 200. Because this is, ladies and gentlemen, a large sample. S is what? And it's 28.5 million. What confidence level are they telling me to use?
95%.
0.95. And you say, but they said 95. I know. This is the what? Decimal representation. So this is why I put this bell here. You go, oh, 95% confidence level. Okay. So back in the old days, we had to do all the z-value stuff and blah, 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 blah. Today, we just use the TI, and we do what? Stat, test, what? Z interval, sorry. So if you wanted, you could write that down too. TI, Z, what? Interval. Okay? You guys ready to try this question out too again? Bless you. Some easy peasy lemon squeezy stuff. All right. Okay, here we go, ladies and gentlemen. Let's go clear this out. Stat. Scroll to the right to test. And then number 7 is what? The Z interval. Good. And yes, keep it on stats. What's the standard deviation? 28.5. Yes, it's in millions, but that's okay. What's the sample mean? 200 million. Good. What's the sample size? Good. What's the confidence level? Good. And hit calculate. That's all you got to do. All right. What do you guys get? 193.07 is less than mu, which is less than what? 206.93. So when you write your answers, you want to give the lower bound value less than the true mean mu, which will be less than 206.93. And then we do say this with 95% confidence. We'll talk about that. But ladies and gentlemen, you are what? You're done. Look at that. Easy peasy lemon what? Squeezy. What do you guys think? I expect an A on every what? Test. say, Mr. Judge, you are what? Mean. I expect you guys to get an A. Because you can do it. Language and what?
Process.
Let's do the next one. Let's see if the next one's interesting. Oh, did you guys do the IQ extra credit?
Not yet.
Okay. I don't know.
They did it without a range.
But be careful. If I don't know, but if you start guessing and you don't want to do it and you just do random stuff like that, it might just say, hey, wait a minute. We don't think you're really doing it. Do you guys know what I mean?
Yeah.
I think you might get that error out of range. 'Cause that's another way of just saying, hey, come on.
It's like seriously.
Right. That's their way of saying, are you serious? Take it serious. Okay? Well, I don't know. It's an IQ test.
You need to see if you're mensa.
Yeah. Try it out. Or if you said, you know what, Mr. Judge, I don't want to do that. That's fine. You know why? Maybe you're a little sensitive. That's okay. I'm sensitive about some things. And so you have another option. What could you guys do?
Attend.
Yes, attend the African American in STEM workshop, whatever that is. It's a conversation. You guys can watch that. I'm going to be there. It's from a faculty member. I'm not going to talk. It's some African American math instructor and some others in industry. They're going to talk about that. I think it's going to be interesting, ladies and gentlemen. I don't remember, but I put the information in Canvas. So this is an IQ of attorneys. Let's read. You say, Mr. Judge, it says now what? A survey. A survey, ladies and gentlemen, is the same as a what? A sample, okay? N is 120, because it's a sample of 120 attorneys. And they report, what's their mean IQ? If we just focus on attorneys, what they're saying is that mean is 108.6 with a standard deviation 12.5. Use the what now? 90% confidence level. Okay, use that 90% confidence level to do what? You're going to estimate the true mean, and the true mean is mu. So whenever I do these questions, I do it exactly like I'm showing you guys. I read through it, and I write down in red. I say, oh, here's my sample information. The sample size is 120. The sample mean is 108.6. The sample standard deviation is 12.5. And the 90% confidence, I have to write that as a decimal, and that's 0.90.
Would it give you a different answer if you just put 0.9?
No. And then in the TI, I use Z what?
Interval.
Z interval. So you might even just write that down for yourself, because again, if you know that on a test, everything becomes automatic and quick, because you're training yourself to go through the process. And now in the process, okay, clear. Remember, it's stat and scroll over to test. Is that right? And then you scroll down to number 7, which is Z interval. Good. What's the standard deviation again? 12.5. Good. What's the sample mean? 108.6. See why you guys want to write it down? Sample size is 120. Confidence level is what? 0.90. Scroll down to calculate. And what do you guys see under calculate?
106.72, 110.48.
106, go back. 106 to 106 point what? 72 is less than mu, the true mean, which is less than 110.48. So you got again the what? The lower value and then the what? Upper value. And they're saying this is with 90% what? Confidence. So, ladies and gentlemen, you're estimating a true mean, and what that means is that the true mean IQ is between 106.72 and 110.48 with 90% confidence. Anybody have any questions on this one here? Yes.
So, if we were to give this answer on a test,
Yeah.
would we have to not only put 106.72 less than mu, less than 110.48,
Yeah.
would we also have to state with 90% confidence, and would we lose points otherwise?
No, you don't, but I want to talk about what it means because that's important too. And I think it's a good time to talk about what it means. Now, remember the sample distribution of the means, right? Or the central limit theorem. With the central limit theorem, that sampling distribution of the means has a normal distribution, a bell, and the center of that distribution is mu. You guys remember that? All that idea? And then if I went back to the original formulas here, and you say, you know, Mr. Judge, I recognize that sigma over square root of n from the central limit theorem. And then you got this factor of z for that margin of error. You go, and then this is a large sample. You say, what does that mean? Well, this comes from the central limit theorem. And so what all of these things mean, like the last one we just did, the 90% confidence, here's the idea. This is only one sample of size what? 120. What if and you got a sample mean of 108.6. What if I took another sample of size 120? Would I get the same sample mean? I'd say no, you might get 108.2. So if you get a third sample of size 120, would I get the same sample mean? And I'd say no, you probably get 109. So, but that's only 3 samples. So you're saying, well, what's really happening? If you take an arbitrarily large number of samples of size 120, you say, is 10 large? No. 100 large? No. If you did this process a gazillion bajillion times, what this means is 90% of the time, the sample means will live between these two numbers. That's what 90% confidence level means. If you went through the process of the same sample size an arbitrarily large number of times, infinity, the sample means, x bars, will live between these two numbers, between the lower value and the upper value. Just like over here, the prior example, what does the confidence level mean? Well, if you take an arbitrarily large number of samples, all of size 65, 95% of the sample means will live between these two numbers. That's the meaning of confidence what? Level. That's what I'm talking about. And again, if you said, what about the prior example? Okay. If you went through the process, 600 data values in your sample, and you computed the sample mean, you did this process an arbitrarily large number of times, 99% of the time, the sample mean would be between these two numbers. That's the meaning of confidence level. It comes from that simulation and repeating that process over and over again and then seeing where the sample mean will live. That's the meaning of it. So it's important for you guys to even know the meaning of it. But it's also important you know, hey, what are you doing? You're estimating the true mean, but this is an interval estimate, meaning it's between two numbers. All right, let's look at the next example. Well, we don't have a next example. Here's what I'm going to do for you guys. I'm going to make up an example. What kind of things do you guys care about? Makeup? Should we do a makeup example? I don't know. Cars? Okay, how about if we make up an example? How about if we do, you guys care about school? Okay, I think I have one. Let me have you guys try this one. A sample of 50 college students reveal a mean of what? 5.6 absences per semester, with a standard deviation of 1.2 absences. Use the 95% confidence level to estimate the true mean. And that's the true mean number of absences. All right, you guys okay with that? Hopefully students aren't what? Absent. Okay, let's give you guys some time. Try this one out. Let's see what you get. Okay, ladies and gentlemen, let's try this out, okay? All right, here you guys go. When we read this, it says what? Sample of 50. Sample size, is that right?
Yep.
Reveal a mean of 5.6 absences. And I should say per semester, per class, but okay. With a standard deviation of 1.2.
Yep.
Use the what?
95%.
95% confidence level to what? Estimate the true mean. Okay, so what I'm going to write down now, ladies and gentlemen, sample size is 50. That's large. Sample mean is what? Sample standard deviation. What's my confidence level? 0.95. Okay, CL. Okay, all of this information is going to be used right in here with what TI, Z what?
Interval.
Z interval. All right, let's get out the TI. Here we go. Stat. Test. Z interval is number 7. Okay. It's under stats. Good. What's the standard deviation? Since this is large, we can say sigma is the same as S, 1.2. Sample mean is at 5.6. Sample size, 50. Confidence level. And then we hit what? Calculate. Now let's go out to the nearest thousandths if we can. What do we see? 5.267. Good.
Which is less than 5.933.
5.933. So again, ladies and gentlemen, the true mean is going to be between these numbers here, and then we can say this again with what?
90%.
95% confidence. And there you guys go. Okay. So this is the true mean absences are somewhere between 5.267 and 5.933. What do you guys think? Is that okay? All right. How about this? Anybody going to have a good lunch later? What are you guys having for? Oh, we got some. What are you going to have? Oh, you're having Chick-fil-A. Okay. What do you get at Chick-fil-A?
Depends on what I'm feeling. So I'll get like the spicy chicken sandwich with like a Oreo sheet.
Okay.
If I'm feeling like at a 40.
All right.
Or, yeah, that's pretty much it with like a Dr. Pepper. But yeah.
There you go. Doesn't sound too bad to me.
Dr. Pepper.
What do you get from Chick-fil-A?
You know, when I was younger, I used to eat at Chick-fil-A all the time. I'd get the grilled chicken sandwich, and I would put barbecue sauce on it.
So much.
You know, back in the day, I think it was the grilled chicken, I think. Or maybe it was the other chicken. But I put barbecue sauce on it.
The buffalo sauce from there is pretty good.
Yeah. That's what I would get, Chick-fil-A. But, you know, I hate to say it. Sometimes if you eat like fast food like that, it doesn't feel like you've eaten something. Maybe when you're younger it does, I don't know, but like for me, if I eat that, I don't feel full. I don't know if that makes any sense.
I need to have like a fruit with it or something.
I don't know. Yeah, because you have to have fiber with it.
Yes. Like an apple.
Yeah. If you have fiber, it'll help you feel full. But if you don't, you're like, I can probably eat 3 of these Chick-fil-A chicken sandwiches. And then you don't feel full, you feel sick. Too greasy? No? You guys are big on Chick-fil-A?
My order's so expensive. Mine's is like 20 bucks.
I hate that. That's why I'm giving you guys this example.
Chick-fil-A is expensive.
They got fruit cups.
Food cups? Fruit cup? Oh, they do? Is it sweet fruit though?
Good. It's like grapes and
Strawberries.
strawberries, apples, I think.
You get the mac and cheese? Are you one of those, like my daughter? You know what has good mac and cheese? Costco.
Actually, yeah.
Costco mac and cheese is pretty good when you get that. Ask your mom next time you're at Costco. Get that mac and cheese. That's on the Judge family list for Thanksgiving. Just so you guys know, I always have to have a side of mac and cheese for my daughter because she likes that Costco mac and cheese.
Okay, but Costco hot dogs hit different.
Yeah. So this is kind of like the essence of why I ask you guys these questions, because, you know, we can estimate this. So we can say a sample of 100 lunch receipts. And I hate to say it, this stuff's getting expensive. Ooh, man. Reveal, this is just lunch. a mean of $22.65 with a standard deviation of $4.22. Use the 90% confidence level to estimate the what? True mean. So, to show you guys this stuff, not too bad, right? You got a sample of 100. That's N. That's your sample size, right? So you got a sample of 100 students. They all went out to lunch, and they have a receipt. And then the receipt, you compute the mean, and you find it to be what? 22.65 with a standard deviation of what? 4.22. Sample mean, sample standard deviation. Use the what? Use now the what? 90% confidence level to what? Estimate the true mean. So there's going to be a true mean here. That's mu. So like I said, read through it and then write down everything you need. And they're going to give you the sample size. You get the sample mean. You get the sample standard deviation, 4.22. Confidence level, they're saying is 90. Put the decimal. So all of that gets into the TI under Z what? Under your Z interval. So double check, ladies and gentlemen, is that all? Are we okay so far with all of this? So we go to stat. It's right in the middle there. Scroll to test. Number 7, Z interval. Okay, standard deviation. 4.22. Okay. Oops. Let's go back. Sample mean. Is that 22.65? What's your sample size? 100. What's the confidence level?
90.90.
Scroll down and hit what? Calculate. What do you get?
21.956 less than mu, which is less than
20.956. Less than mu, less than what?
23.344.
Okay, I ran out of space, so I'm going to move it all down. Lower value. Upper value, and this is the true mean again. And then we say this again with 90% what? Confidence. So this is the cost, ladies and gentlemen, of lunch. So you can think, oh, you're going to spend between 21.9. And really, if you guys want to know the truth, estimate this to the nearest what? Penny. Yeah. And then you say, Mr. Judge, why? Why change this to the nearest penny? Because you're talking about what again?
Money.
This is money. Okay, these are dollars now. So this is how people work with this. And this is how people think about it. You're going to spend between $21.96 and $23.34 on your lunch. I'm not even going to bring up, oh, what's that expensive burger place?
Five Guys?
Five Guys. Try to go to Five Guys for lunch.
Oh, what's the other one? Oh, Shake Shack.
Is that expensive too?
Oh hell yeah! You'll spend 12 or 13 just for the sandwich.
That burger.
I spent $40 at Shake Shack for just me and one other person. It was close to $48. The shakes are like $7.
And they ain't even that good.
I think I like Five Guys a lot better. You only had it once in your life?
Yeah, but then it made me gross, so I never went back.
Tell me about it. I used to have my daughter, I pick her up for lunch. Pick her up for school. And every time I pick her up from school, what does she say? Dad, I'm hungry. Those girls like to eat.
You could have taken her to McDonald's. You should take her to Five Guys. There's food in the fridge.
And then she'd have to eat something good. She wants Five Guys. So I'd have to go to Five Guys and I would pick, you have a burger, they're expensive, but they're good.
If you do it all the way, yeah.
I don't know why they're so good. I think because it's fresh. They taste like home. Do you guys know what I mean?
It tastes like an actual backyard burger, not like a factory burger.
Yeah,
I think because
it's fresh.
my brother works at McDonald's, he says they use like this weird press griller thing that they use steam and stuff.
I used to watch as a kid, and I used to have fun watching McDonald's. They used to cook at McDonald's back in the old days. You'd watch them in front. They'd be in front of you cooking all the burgers, doing all the fries. It was interesting. And they actually would cook them. You would see them do that. And they're actually better back in the day. That's the amazing thing. They were good. Now they're like, oh, this is horrible. It's like eating cardboard.
Sometimes it's tasteless too.
There's something wrong. But I used to enjoy watching them. It was better. I hate to say it. It was a lot better. In-N-Out's, that's why In-N-Out's probably better.
And they're cheaper too.
They are cheaper. That's why people go, because it's kind of a somewhat reasonable place.
It's like what, $5 or $6?
Five Guys ain't so reasonable.
It's like $3. I think it's $3.25 if you just want the burger.
That's right.
It's In-N-Out, right?
It's very reasonable, comparatively say.
That's why when my niece is like, yeah, I'm hungry. I'm like, okay, let's go to In-N-Out.
Yep. That's why you see lines at 6 p.m. going down the street.
That's why you don't go in those lines. You walk inside.
Yeah, you walk inside. You don't stay in. I don't stay. I have to walk inside.
I've literally walked inside, and then I see the car I would have been behind still.
Yeah, you can order your food, you can sit down and eat, and then you could leave, and you see that car that you would have been behind.
Window.
Tell that to my mom. She doesn't like to get out of the house.
Old people like ourselves, we don't like getting out. You can tell her that. Well, I don't want to say how old she is, but I don't want to. She's up there with me probably.
But then I make her feel bad. I'm like, you're making me go alone inside, but I'm still in there. And she feels bad.
Yeah, she still feels bad, and she goes.
That's what you do.
Then we have to go
Gaslight
to
and guilt trip.
That's my daughter.
Gaslight and guilt trip.
Dad, I want Five Guys. I want something good. Anyway, here you guys go. I'm going to put your homework estimation. We just started. We're going to do some more estimation tomorrow. I eat way too many burgers. Craving a what? What is that? Bambasco? Is that like a quesadilla?
It's basically like a torta ahogada, but it's not really.
Okay.
Take your time.
Alrighty, we'll see you guys tomorrow. I'm gonna put your estimation here, okay? Yeah. Oh, what? No, sorry about that. You too. Take care. I like the bangs. I like your bangs. You too.